Hello, I'm Scott Otto, and I've been posting a lot on LinkedIn lately about AI and machine learning. And I talked a little bit about catastrophic forgetting, and I want to give you a little demonstration of it. So I'm going to share some code with you and show you how this happens. It's pretty common and well-known effect in machine learning, but people don't really talk about what it means. So I've written a document that is kind of a companion piece to this video. But this video is just go over some code and show you in real time an example of catastrophic forgetting. All right, so here's my code. It's in PyTorch. I also have a version of it in Python, if anybody wants access to that. So the main part is there are data sets available for showing you catastrophic forgetting. But in this case, I'm using a couple of commonly used data sets for machine learning, MNIST and CFAR. For this example, we're just going to look at the MNIST data because it runs faster. So this first block of code that I'm going to run is just creating a training set, and then this second test set, which is split into further training and testing. So this should only take a second. Okay. And so we'll actually split up what I was calling the first training set into training and testing. So you have 48,000 for training, 12,000 for testing. So that's 60,000 altogether. I think there was 70,000 altogether. Take the other 10 and use that for retraining. So what we're going to do is, first of all, for people who aren't familiar with MNIST, MNIST is a data set full of handwritten digits from 0 to 9. They're images of these handwritten digits. And we're going to train the network up, standard deep net, train it up on the digits using this 48,000 inputs. And then we're going to test it on 12,000. Any deep net you make is going to do really well on this task, and we'll show you that. And then what we're going to do to show you the forgetting is that after it's been trained and tested, we're going to retrain. So we start with the weights where they were after the initial training, and we just show it 2s and 6s. And then we retest, and we'll show you that it's getting better at the 2s and 6s, but it's starting to forget the other digits. Okay, so this other block of code here is splitting out the 2s and 6s from the rest of this second training testing data set of 10,000 examples that I have. So here you're going to have 8,000 for the rest and close to 2,000 for just the 2s and the 6s. And then even within that 2,000 of the 2s and 6s, you need a training set and a test set. And so I split that up here. So you have close to 1,600 in the training and about 400 in the test set. So that's with the 2s and 6s mixed. We're going to do a second example of the catastrophic forgetting. And this time we're going to do all the 2s first and then all the 6s in the retraining. And you'll see that the forgetting gets much worse when you do that. So the first group up here is kind of when the 2s and 6s are interleaved. And then this set down here that I'm going to run right now is with the 2s and 6s separated out. So I've separated out the 2s and 6s, and then within the 2s and 6s, I have to break that up into training and testing for the 2s and 6s. So all this is just me going through and kind of taking a very popular data set and splitting it up in a way that I can use to show catastrophic forgetting. And this code I'm not going to run, but this is, you run it, you get to see what the data looks like. Last time I ran it was just on the data with the 2s and 6s. So in the first training set, you have all 10 digits in there, but that's what they look like. But we're not going to do that part. And here you can see the code for the deep net. It's fairly standard. There's 3 layers. Each layer has convolutions, batch normalization, max pooling, and then dropout. And then you have your output layer and your definition for the forward propagation. So we're going to run that class to get that set up. Okay. And we're not going to go through the training for that because it's already been trained. So we're going to zip ahead here. And we're going to come here to this, create a new model. And we're going to use the weights from the initial training and testing. And just to make sure that that model is working correctly and like we remembered it. So it generally was getting 99% when I trained this up. And so we're going to run it again on the test data and see if we get 99% accuracy now that I've reloaded the weights. And you can see it is 99%. And you'll see that the 99% is fairly consistent across all the categories here. So straight 99s and a couple of 98s for 3 and for the digit 9. Okay, so now we're going to train it with the 2s and 6s interleaved. So we're going to run this block here. And we'll come back later to this other block, which is where the 2s are first and then the 6s in the training. So that's non-interleaved. All right, so you set your criteria, which is cross entropy loss and learning rate 0.001, very standard. Nothing fancy here on the deep net. Like I said, just about any deep net you want to code up, you're going to get 99% accuracy on the MNIST data. But here's what happens when we, now we're going to run it, retrain it using the 2s and 6s. So we're starting with the weights that we've trained up already and got 99% accuracy. And now we're running it on the 2s and 6s. And we're going to see what happens. So in the original training and testing of the model, we did 10 epochs. Here we're doing 12 just because it's a smaller data set. It runs faster. So it didn't take much extra time to run it for a couple extra epochs just to make sure that we gave it a good chance to learn. Okay, so it's finished training. Now let's go down here and see the results. Okay, so on the 2s and 6s, it's learned them 100%. And now we want to see how it works. So that's just on the test set of 2s and 6s. So you shouldn't expect anything but zeros for the other categories. Now let's go see how it did on all 10 categories, going back to that test set, which is over here. So this is really just the same code repeated from up above. Okay, so performance has dropped from 99% to 83%. And you can see a lot of forgetting is starting to happen. It's down to 54% on 0, 61% on the 7s. 2s and 6s are 100% because it just learned those and hasn't forgotten them yet. These numbers can vary every time you run it because we're not doing a cross-fold validation. Normally you would do that when you're training a network so that you know exactly, have the best confidence in what the results are going to be when you get out into the real world. Here, this is just being done to show the effect of catastrophic forgetting. So we don't care exactly how much catastrophic forgetting happens. We just want to show that it happens. All right. So that was with the 2s and 6s interleaved. So we lost like 16% accuracy. We have lost some categories almost 50%. So we'll go back now and do the 2s first and then the 6s and see how that impacts it. Okay, so here we go. This is run the second training using the 2 categories that are not interleaved. Oh, wait, you know what I'm going to do? We're going to start from the same starting point as the example we just did. So we're going to go back up here. We're going to create a new model using the weights that were originally trained from the original training. So that's the weights that got the 99%. So we're loading that up. And we're going to test it again just to make sure we're getting 99% accuracy. And again, because we're not doing cross-fold validation here, the numbers can change slightly. It's almost always, it's been 99% every time I run it. But sometimes you'll see we don't have 98. We have a couple of 97s in here. So you get a little variation there. Okay, so now we create the data for this training with the 2s and 6s not interleaved. And again, same criteria for the model. And because we're doing this not interleaved, we do 12 epochs of the 2s and then 12 epochs of the 6s. So that has finished running. And now we'll test it to see how the training went. So if we look at this with the 2s and 6s, remember last time 2s and 6s, it learned them both to 100% accuracy. Here, it's only 86%. Why? Because it learned the 2s first. So it learned the 2s to 100% accuracy. But then while it was learning the 6s, it started to forget the 2s. And so when you test it at the end, the 2s have dropped to 72%. Now let's see what happens when we test it on the original test set with all 10 digits in it. 44%. And look at this forgetting going on here. 0 is almost completely forgotten. 5s are almost completely forgotten. 1 is almost completely forgotten. 6 is still 100%. 2 is 81% because I just learned those. But everything else has been forgotten. And only 12 epochs. You're down to like a random chance with recognizing other digits. So that is our little demonstration there. So that's just an example of how catastrophic forgetting happens. And I talk a little bit more in the document that I posted on LinkedIn about what this means for deep nets and how it addresses some of the limitations that deep nets have. And people don't usually talk about that. So it's kind of important. All right. Thanks for listening. And if you want the code, I mean, it's a very simple code. You can find it online, pretty much any deep net. But if you want this particular code, I'm happy to share it. You can just message me on LinkedIn. Thanks.